If dark theory is to be understood on its own terms, then it cannot begin where physics usually begins. Most physical theories start from a furnished world. They assume some already given arena in which events occur: spacetime, fields, particles, states, laws, constants, symmetries. Even when the mathematics is subtle, the opening move is often the same. The world is treated as though it is already there in a meaningful form, and the task is to describe how it behaves. Dark theory steps back from that entire arrangement. Its first question is not, what are the laws of the universe? It is, what must be true before a universe, in the strong structural sense, can exist at all? That shift matters. It moves the discussion away from already formed entities and toward the preconditions of form itself. It asks what can be said before geometry has been granted, before time has become ordered, before matter has acquired stability, and before law has become applicable. In other words, it begins earlier than the normal language of physics allows. The proposal is severe but simple. At the deepest level, one cannot begin with objects, because objects already presuppose some degree of persistence. One cannot begin with space, because spatial separation already presupposes stable distinguishability. One cannot begin with time, because temporal order already presupposes retained states capable of meaningful succession. Even causality is too late, because cause and effect require identifiable relator and an ordered structure in which transformation can be tracked. So the opening of dark theory is stripped down to the minimum admissible move: differentiation. Not things which differ, because that already smuggles in the notion of things. Not entities in relation, because that already assumes entities and the meaningfulness of relation. Simply differentiation itself, the primitive fact that one determination need not be identical with another. This is the first structural cut. It is the earliest separation from undifferentiated indeterminacy. At this point, there is no world in the familiar sense, only the possibility that determinacy may begin to separate from what is not yet resolved. That sounds abstract, and it is, but it is abstract for a reason. Dark theory is not trying to decorate the known universe with new language. It is trying to rebuild the ground from which a universe could emerge without quietly importing the very notions it seeks to explain. This is why difference comes first. Identity does not sit at the beginning as a free gift. Stability does not arrive pre-installed. Persistence is not assumed. These are achievements, not primitives. They must be earned by structure. The opening problem is therefore not how already existing things interact, but how anything could become sufficiently stable to count as a thing at all. That is where recursion enters. Primitive differentiation alone is not enough to produce a world. A fleeting distinction by itself has no obligation to endure. It may flash and vanish without leaving any retained structure. It may fail to compose with further determinations. It may be incapable of bearing relation, memory, or recurrence. A universe cannot be built from distinctions that never survive their own becoming. So differentiation must be revisited. It must be acted upon again. It must pass through recursive return. This is the decisive turn. In dark theory, recursion is not merely repetition, it is the condition under which primitive differentiation is tested for survivability. Once differentiation acts back upon differentiation, the central question becomes whether a pattern can retain enough consistency through re-entry to remain structurally available. Some differentiations collapse under this pressure, some fragment, some interfere with themselves and dissolve, others begin to hold. That is the earliest form of ontological selection. Selection here is not biological, not observational, and not merely statistical. It belongs to the genesis of structure itself. A pattern that cannot bear recursive return has no durable claim to existence. A pattern that can survive re-entry, preserve some self-consistency, and remain available to further refinement begins to acquire structural status. This is the point at which dark theory begins to depart sharply from ordinary metaphysical instinct. Common intuition imagines identity as primary. A thing is thought to be itself, and only afterwards does it enter into processes or relations. Dark theory reverses that order. Stable identity appears only after recursive pressure has narrowed the field of differentiation enough for some determinations to maintain themselves through repeated refinement. Identity is therefore downstream of recursion. It is not what makes structure possible. It is what structure becomes when recursive activity stabilizes. That shift is one of the deepest in the whole program. Reality, on this view, does not open as a populated domain filled with self-standing units. It opens as a differentiating field under recursive pressure. Most of what appears there never becomes durable. Most of it never crosses into stable form. What later counts as a structured reality arises only where recursive differentiation reaches sufficient consistency to support retained identity. This is why fixed points matter so much in the formal development of the theory. A fixed point is not treated as an incidental mathematical convenience. It marks a regime in which recursive activity no longer destroys the pattern that supports it. The operation returns, but the structure does not disintegrate under that return. It remains available to itself. That is one of the earliest signatures that reality is ceasing to be merely fluctuating differentiation and beginning to acquire durable form. The phrase stable refinement is important here. Dark theory does not move directly from indeterminacy to finished objects. It moves through refinement. Structure is narrowed, tested, revisited, and stabilized. The world is not born as a set of completed things. It emerges through a filtering process in which only certain differentiations prove capable of continued structural support. Once this is seen, several later claims of the theory become much easier to understand. Geometry, for example, cannot be fundamental. Geometry requires stable distinguishability, some reliable mode of relation, and a sufficiently coherent regime in which separations can be encoded without immediate collapse. If differentiation has not yet stabilized, then geometry has no ontological right to appear. Space is therefore not the womb of structure. It is a later representation of achieved structural separation. The same applies to time. At the ordinary physical level, time appears obvious. Events occur in sequence, systems evolve, histories accumulate. But sequence in this strong sense requires retention. If no structural identity can endure through recursive return, then there is nothing robust enough to order. There may be unresolved variation, but not yet temporal structure in the full sense required by physics. Time, like geometry, belongs to a regime that has already crossed a threshold of coherence. So the opening of dark theory is pre-geometric and pre-temporal not as a rhetorical flourish, but by necessity. If one begins with space and time already present, the question of their emergence has been bypassed rather than answered. This is also why dark theory treats the conventional image of the beginning with suspicion. The familiar cosmological imagination asks what happened at the start of the universe, as though the origin were simply an event located at the earliest point of an already meaningful timeline. But an event presupposes a world in which events can occur. It presupposes enough structure for change to be intelligible, enough retention for succession to matter, and enough coherence for the language of before and after to apply. Dark theory places the true origin earlier than that. The origin is not first an event within space-time. It is the long ontological struggle by which a regime capable of space-time becomes possible. Before closure, before geometry, before causal order, there is no obligation for the universe to resemble the categories by which later physics describes it. There is only the problem of whether primitive differentiation under recursive return can stabilize into something capable of bearing a world. That is a far more demanding beginning than the usual picture allows. It also gives the theory its distinctive seriousness. The opening is not a poetic gesture. It is a refusal to smuggle finished structure into the foundations. Once recursive differentiation begins to stabilize, however, a path opens. Stable refinements do more than persist. They become candidates for composition. They can begin to support interaction. They can bear encoding. They can be nested, related, and integrated. At first, this does not yield the familiar world all at once. It yields only the possibility that some local regimes of structure may begin to hold together strongly enough to support further organization. This is the embryo of closure. Closure, in dark theory, is not just a neat formal property. It is the point at which a refinement regime ceases to leak its identity under further operation. A closed structure can sustain itself. It can support recurrence without losing the very character that makes it what it is. Only with closure do deeper ontological achievements become available. From there, the entire argument begins to sharpen. A retained differentiation that can survive one round of recursive return is not yet enough to build a world. To support further organization, it must become increasingly stable under continued re-entry. It must cease leaking its character under the very operations that formed it. It must become a stable refinement in the strong sense, not merely something that lasted once, but something that remains available through repeated structural pressure without immediate collapse. This is where stabilization first becomes unavoidable. Stabilization does not mean immobility. It does not mean that change has stopped. It means that change has entered a regime in which some pattern of determination can persist through further activity without losing its structural character completely. A stable refinement is one that continues to bear itself through operation. It is not untouched by recursion, but it is not erased by recursion either. Something of it survives and remains supportable. That is an enormous step. It means identity is beginning to appear, though not yet as a metaphysical absolute. Identity at this stage is not a timeless essence. It is structural retention. It is the achievement of enough coherence under recursive refinement for a pattern to remain available as itself across repeated operations. This is why dark theory treats identity as earned. Identity is what a pattern becomes when it has passed through enough recursive pressure to hold together without immediate dissolution. This is also why the formal work around fixed points is so important. A fixed point in ordinary mathematics can seem like a technical notion, a value or structure that remains unchanged under a given map. In dark theory, the significance is deeper. A fixed point marks a regime in which recursive transformation reaches self-maintaining consistency. The operation returns, but the structure does not disintegrate under that return. It remains available to itself. In ontological terms, that is one of the earliest signatures that reality is ceasing to be merely fluctuating differentiation and beginning to acquire durable form. The word durable matters. The question is not whether something can appear once. The question is whether it can remain structurally available through repeated refinement strongly enough to support further composition. A world cannot be assembled out of single flashes of unresolved distinction. It requires retained structure. It requires patterns that can bear revisitation. This begins to explain why dark theory is so concerned with compactness, closure, and finite support in the later foundational papers. A stable refinement is not merely one that lasts for an instant. It is one that can be housed. It can be bounded in the structural sense required for continued integrability. It is no longer a leaking process with no local hold. It begins to take on enough internal consistency to support further relation. At this point, a crucial shift occurs. Once stable refinements exist, reality is no longer just a field of transient differentiating acts. It becomes a layered domain in which some patterns have acquired enough persistence to serve as structural supports for further development. This does not yet mean geometry has appeared. It does not yet mean time has appeared in the later physical sense. But it does mean that the first local achievements of world form are beginning to emerge. The transition here is subtle and easily missed. One might imagine that once a stable refinement appears, the next step is simply more complexity. But dark theory is not about complexity for its own sake. The next step is not proliferation, it is integrability. A stable refinement must not only persist in isolation, it must be capable of entering into higher structural relations without ceasing to be itself. It must be composable. This is what opens the door to closure in its deeper sense. Closure is one of the most important words in the whole corpus, and it must be handled carefully. It does not mean mere completion, nor does it mean circularity in any loose poetic sense. In dark theory, closure names a regime in which a refinement can support recursive return without structural leakage. The operations relevant to its existence no longer force it into disintegration. It holds sufficiently within itself to remain available as a coherent support. This is why closure is more than persistence. Something may persist weakly and still remain unstable, diffuse, or unable to support further structural ascent. Closure marks a deeper achievement. It means that the refinement has become internally supportable enough for the next ontological levels to open. And this is the first great structural ascent of dark theory. The movement by which the possibility of determination becomes the possibility of retained form. Once this is understood, several later features of the theory begin to look much less mysterious. Why is geometry not fundamental? Because geometry requires a regime in which distinctions are stable enough to be encoded. That means closure, or at least approach to closure, must already be in view. Geometry is therefore not the starting point of order. It is a later expression of successfully stabilized refinement. Why is causality not primitive? Because causality requires more than mere variation. It requires structured succession between retained states. If structural identity cannot persist across recursive return, then there is nothing robust enough to stand in causal order. Causality must therefore wait until stable refinements and their relations become available. Why does dark theory resist treating the early universe as an event in time? Because time itself belongs to a regime in which retained structure can support ordered succession. Before stabilized refinement and closure, there is no reason to think temporal language applies in the full physical sense. All of these later claims rest on the same foundation. Recursion does not merely revisit differentiation, it turns differentiation into a pressure field from which stable structure can emerge. Another way to say this is that recursion creates the first meaningful asymmetry between what can endure and what cannot. This is the seed of admissibility, though the full language comes later. At this stage, one can already see the principle in embryo. Not every differentiation can survive recursive refinement. Not every structural possibility can bear return. The early field is therefore selective. It is not selective because an external judge chooses among possibilities. It is selective because recursive pressure itself filters what can remain available. This is one of the deepest reasons dark theory avoids the modern habit of treating all mathematically describable forms as though they stand on equal ontological footing. Description is cheap. Persistence is expensive. A formal possibility is not the same thing as a structurally supportable regime. From the very beginning, reality is shaped not by what can be imagined, but by what can survive refinement strongly enough to become houseable. There is another consequence too. Because stabilization happens through recursive return, the earliest structural regimes are not arbitrary. They carry a kind of inherited logic from the process that formed them. A stable refinement bears the history of the recursive pressure that made it possible. It is not just a passive object that happened to survive. It is a compression of structural success. It encodes the fact that certain pathways of differentiation proved capable of self-maintenance while others did not. This helps explain why dark theory is so different in spirit from theories that begin with a list of primitives and then work outward. Here the primitives are intentionally minimal, and the later structure inherits its legitimacy from the route by which it became stable. Reality is not assembled from a stockroom of ready-made ingredients. It is stratified out of recursive refinement. That is why this part of the script must linger on stabilization rather than rushing ahead to the more dramatic themes like gravity, black holes, or cosmology. If the listener does not understand how stability is achieved, everything later will sound like reinterpretation rather than emergence. The whole force of the theory depends on this discipline. It insists that the world we know is not merely described differently, it is derived from a deeper sequence of structural accomplishments. Primitive differentiation becomes meaningful only when recursive return begins to separate what can retain itself from what cannot. This produces stable refinements, local achievements of structural consistency that remain available through further operation. Stabilized refinement is therefore the first real ontological gain of the theory. It is the point at which fleeting difference begins to turn into durable form. And once durable form appears, closure becomes possible. That word possible is important. Closure does not arrive everywhere at once. It is not the automatic outcome of any persistence whatsoever. Some refinements remain weakly supported. Some approach closure without fully achieving it. Some may generate precursor behaviors that signal structural tension without attaining full stability. The later corpus spends a great deal of time exploring exactly these intermediate regimes. But the first breakthrough is simpler. Recursive differentiation has now produced local forms capable of support. From stabilized refinement, one can begin to ask how interaction becomes possible. How can one retained structure bear relation to another? Under what conditions does local persistence become composability? How does a closed refinement regime support encoding, dimensional basis, and eventually geometric representation? These are the next steps, and they are no longer arbitrary leaps. They are developments made possible only because recursion has already done its work. There is a very important sense in which this is the true birth of the world, not the world of stars and galaxies, not yet the world of particles, observers, or equations, but the first world in which something can genuinely hold, the first world in which structural identity is no longer a dream, the first world in which return no longer means destruction alone, but can also mean maintenance, retention, and support. This is the moment when primitive differentiation begins to become inhabitable. Everything later in dark theory depends on this transition. Geometry depends on it, time depends on it, matter depends on it, admissibility depends on it. Even the endgame depends on it, because terminal closure has meaning only in a universe whose entire history is a story of structure, attempting to sustain itself through thresholds of support. Once that transition has occurred, one more decisive question presses forward. A retained structure that cannot enter into meaningful relation remains a kind of isolated ontological success. It may hold itself through recursive return, but it does not yet yield a universe. A world requires more than local survivability. It requires structured relation. It requires the possibility that one stable form can bear connection to another without both collapsing into incoherence. It requires composability in the strong sense. This is where closure becomes the hinge of the theory. A structure approaching closure is one that is beginning to sustain its own identity under recursive activity. A structure achieving closure is one in which the relevant operations no longer destroy the form they act upon. It becomes supportable from within the very dynamics that produced it. Once that level is reached, relation is no longer impossible. A closed or sufficiently stabilized refinement can now stand as something available for further structural integration. Before closure, recurrence sorts. It filters. It narrows the field toward stable form. After closure begins to appear, structure can do more than survive. It can participate. That word matters. Participation is the beginning of worldhood. A closed refinement is no longer merely a local survivor. It can now become a term in a larger structural system. It can enter into composition without immediately forfeiting itself. The possibility of interaction is born at precisely this level, not interaction as force between pre-given particles in a pre-given space, but interaction in the deeper sense, the capacity for one retained structure to be meaningfully implicated in the continued form of another. This is why the foundational papers place so much weight on integrability. Integration is not an optional extra added after stability. It is what transforms local retention into relational architecture. If stable refinements could not integrate, then reality would remain a scattered field of isolated closures with no path toward higher organization. For a universe to arise, closure must support relation. At this point, the idea of encoding enters naturally. Once structures can integrate, differences between them are no longer merely fleeting episodes of unresolved variation. They can now be born, preserved, and structurally registered. Encoding means that relation itself begins to carry determinacy. Structure is no longer only maintaining itself, it is beginning to preserve the pattern distinctions by which larger forms can be organized. This is a profound threshold. Encoding is the first sign that the world is becoming legible to itself, not in the conscious sense, of course, but in the structural sense. A refinement regime that can encode distinctions is one in which determinacy is beginning to accumulate rather than simply survive. Differences can now be retained as part of a broader architecture. They can contribute to a relational order instead of remaining merely local achievements. This is where dimension begins to make sense in a fuller way. In standard physics, dimensions are often treated as given features of the arena. There are so many spatial dimensions, perhaps one temporal dimension, and the theory begins from there. Darke Theory refuses that move. Dimension must itself emerge from the logic of structured relation. A dimension is not primitive. It is a stable basis of distinguishable encoding within a closed or sufficiently integrated refinement regime. That means dimension is not a container in which structure sits. It is a structural consequence of how distinctions can be reliably preserved and organized once closure and relation have been achieved. The world does not appear inside dimension. Dimension appears as the world becomes capable of encoding stable distinctions in a basis-like way. This is the first real outline of shape, not geometry in the full later sense, but the precondition of geometry. Once stable relations can be encoded across an organized basis of distinctions, the idea of extension begins to become meaningful, not as an assumption, but as a derived feature of structural legibility. A world is beginning to take on form, and from here geometry stops being mysterious. Geometry is not the ground of relation. It is the representation of sufficiently stable relation, once encoding has crossed a threshold of coherence. Space is not where differences live from the beginning. Space is how a matured closure regime can express the structured separations it has become capable of sustaining. The same applies to causality. Causality is not a primitive law imposed on a featureless domain. It arises only once stable relation, persistence, and ordered transformation have become possible. Before closure, one may have variation, tension, and recursive activity, but not yet causal order, in the strong sense used by physics. Cause and effect belong to a world already rich enough to retain its own transformations. This also clarifies why time is still not fully primitive even here. At the level we have now reached, the conditions for ordered succession are beginning to appear, but time in the rich physical sense still belongs to a later stage in which closure, relation, and persistence have accumulated into durable world history. What we have here is the structural basis for temporal order, not yet the full story of temporal experience or cosmic evolution. That will come later. For now, it is enough to see that succession becomes meaningful only once retained structure can support it. So, what has happened so far is not small. We have moved from primitive differentiation to recursive filtering, to stable refinement, to closure, to relation, encoding, dimensional basis, and the preconditions of geometry and causality. The climb is now visible. Nothing has been granted for free. Every layer has had to earn the next. That earned quality is essential. It is what makes dark theory feel structurally grounded rather than merely speculative. Each step exists because the earlier step makes it possible and, in some sense, necessary. This is also the point where one can begin to understand why later physical concepts can be reinterpreted so radically. If geometry emerges from closure rather than standing prior to it, then curvature is not simply a feature of an independent spacetime manifold, it becomes a signature of how coherence is distributed within a matured relational regime. If matter appears later as persistent closed structure, then matter is not an alien ingredient inserted into geometry. It is one of geometry's structural achievements. If gravity later becomes interpretable as a coherence gradient, that too will no longer feel like a poetic metaphor. It will follow naturally from the architecture now being built. But before that can happen, one deeper filter must come fully into view. A shaped world is still not the same as a supportable world. Once structure can exist, can every possible structure persist? The answer is no. And this is where the theory becomes much sharper. A common habit in modern thought is to assume that if something can be written down coherently enough, then it stands as a legitimate possibility of the real. Darke theory rejects that habit. It draws a distinction between formal describability and structural support. A regime may be mathematically expressible while still being too burdensome, too unstable, too coherence demanding, or too structurally unsupported to endure as a real inhabitant of the world. This is the full entrance of admissibility. Admissibility is not a decorative philosophical term. It is one of the central load-bearing concepts of the corpus. It names the difference between structures that can actually be borne by reality and structures whose persistence would require more support than the architecture can furnish. It is the principle that says existence has a cost. That line matters. Existence in Darke theory is not a neutral platform on which all abstract possibilities stand equally. Reality is selective. It is built through thresholds of support, and only certain forms can survive the burdens those thresholds impose. Stability has to be maintained. Coherence has to be housed. Integration has to be paid for. If a regime demands more than the structure of the world can sustain, then it does not become part of durable reality, no matter how elegantly it may be expressed. This is the point at which the theory grows teeth. Up to now, the story has been mainly constructive. It has explained how the world is built upward from primitive differentiation into stable refinement, closure, relation, and the first structured basis of a world. But if the theory ended there, it would still be too permissive. It would tell us how structure becomes possible, but not why some regimes fail, why some idealizations break down, or why certain mathematically definable states should never be expected to persist in the real. Admissibility answers that. It says that reality is not the sum of everything that can be defined. It is the residue of what can survive. More precisely, it is the residue of what can survive while carrying the burden of persistence across the relevant width, lifetime, and level of coherence demanded by its own structure. That burden can take several forms. A regime may fail because it requires exact coordination across too large a structural extent. It may fail because it demands persistent fine-tuning under recursive pressure without compensating closure. It may fail because it cannot recover from local leakage or competition. It may fail because its own internal complexity outruns the support available to it. Or it may fail because it depends on a level of ideal symmetry or continuity that reality cannot indefinitely maintain. In every case, the issue is the same. The regime is not excluded because it is logically contradictory in the narrow formal sense. It is excluded because the world cannot carry it. This is one of the deepest changes dark theory introduces. It replaces the question, is this formally possible, with the harder question, can this be structurally supported long enough, widely enough, and coherently enough to exist as a durable regime? That is a much stronger standard. And once that standard is adopted, a great deal of the later corpus begins to align. The mathematical exclusion papers, the empirical precursor papers, and the cosmological threshold papers are no longer separate moods of writing. They are applications of one principle. Some regimes fail because they ask too much of structural support. Some appear only transiently because they approach a threshold they cannot cross stably. Some leave residual traces because even their failure has a recognizable architecture. This is why admissibility does not simply divide the world into real and unreal in a crude way. Dark theory is more nuanced than that. A regime may be fully admissible, meaning it can be stably housed and persist as part of the structured world. A regime may be transiently admissible, appearing briefly as a precursor, tension state, or approach to threshold without being able to persist indefinitely. Or a regime may be inadmissible in the strong sense, formally articulable, perhaps even locally approximable, but unable to survive as a durable mode of reality. This layered view matters because it lets the theory speak with precision about very different classes of phenomena. A stable geometric regime is not the same kind of thing as a pre-failure coherence pattern in a biological system. A fully persistent closure structure is not the same as a mathematically defined pathological solution whose burden outruns any plausible support. A cosmological threshold object is not the same as a stable low-energy background regime, yet all of them can be understood under the same broader question: what can reality actually bear? That question becomes the hidden backbone of the whole program. It also explains why dark theory consistently resists inflation of ontology. The theory does not multiply primitives freely. It does not hand out existence cheaply. It assumes that if something is real, then reality must be doing the work of supporting it. That means structure is never just there. It is always being paid for by the conditions that allow it to persist. This gives the theory a very different tone from many conventional frameworks. In standard approaches, one often begins with a generous arena and then study what dynamics occur within it. In dark theory, the arena itself is already the outcome of structural success, and what occurs within it remains constrained by further support conditions. The universe is not a blank permission field. It is a coherence economy. That phrase is worth dwelling on. A coherence economy is a world in which persistence, relation, and structure are limited by what can actually be supported. Nothing is free. Long-range exactness is expensive. Persistent high-order coordination is expensive. Perfect retention under pressure is expensive. Structural width without leakage is expensive. Any regime asking for these must justify its existence by being supportable in real terms, not merely by being definable. This is why the coherence burden principle becomes so central later. But even before that formal articulation, the intuition is already present here. Existence is not just about appearing once. It is about being housable, being maintainable, being able to survive the recursive and relational costs implied by one's own structure. Seen in this light, admissibility becomes the true bridge between emergence and exclusion. Without it, dark theory would explain how structure rises, but not why structure is limited. With it, the theory can say something much stronger. It can explain both why certain regimes emerge and why others fail. It can tell us why stability has architecture, why breakdown has architecture, and why many celebrated formal possibilities may turn out to be ontologically overdrawn. This is also the point where the theory begins to prepare the ground for its broader reach. Once admissibility is on the table, one can start to reinterpret long-standing questions in mathematics and physics through a different lens. The issue ceases to be merely whether a solution exists in abstract description. The issue becomes whether the corresponding regime could carry the burden required of it. Can it sustain the demanded regularity? Can it maintain the necessary coherence? Can it remain structurally housed without collapse, leakage, or inadmissible support cost? That is why the later papers on Navier-Stokes, Yang-Mills, P versus NP, and the Riemann line all make deeper sense once admissibility has been understood. They are not random excursions, they are stress tests of the same architecture. They ask whether certain pathological, exact, or indefinitely stable regimes are genuinely supportable, or whether they belong to the large class of structures that mathematics can describe more easily than reality can bear. The same logic extends into empirical systems too. A pre-seizure phase pattern in EEG, a pre-failure organization in self-organized critical systems, a structured signal preceding rupture in seismology, or a phase condition transport anomaly in turbulence or plasma systems may not represent permanent regimes, but they may still be structurally informative. They may appear precisely because a system is moving through a burden landscape toward threshold. In that setting, admissibility is not only about what persists forever, it is also about what kinds of transient approach become visible when persistence is under stress. This makes Darke theory unusually powerful because it does not only describe finished stable worlds, it also describes the edge cases, precursor states, structurally loaded instabilities, residual signatures of regimes that cannot fully sustain themselves. That is a richer ontology than a simple, stable, unstable binary. It is one of the reasons the corpus feels internally connected across such different domains. We can now state the deeper point plainly. Once the world has become capable of stable structure, a further filter comes into force. Not every formal possibility can be carried into durable existence. A regime must be structurally supportable. It must be able to bear the coherence burden implied by its own width, lifetime, regularity, and integration demands. Admissibility is the principle that distinguishes what reality can house from what it cannot. That principle changes the entire tone of the theory. The universe is no longer merely an emergent structure, it is a selective structure. It is not enough for a regime to be imaginable, it must be payable. And that one idea governs almost everything that follows. It governs how quantum structure is interpreted. It governs how geometry matures into curvature. It governs how matter is understood as persistent closure. It governs why gravity can be read as a coherence gradient rather than a primitive force. It governs why some mathematical ideals remain unrealized. It governs why entropy and irreversibility arise as structural losses rather than mystical tendencies. And in the end, it governs why the universe itself cannot remain indefinitely open to generative novelty, because the endgame, when we eventually reach it, will turn out to be nothing other than admissibility pushed to its terminal limit. But before that, the theory must still take another step. Now that the world has shape and now that admissibility tells us which regimes can actually persist within that world, the next question becomes unavoidable. How do geometry and physics mature together? How does a closure-bearing relational architecture become the curved, matter-bearing, gravitating universe we recognize? This is where dark theory makes one of its most important moves. It does not treat geometry as the primordial stage on which matter later appears. It does not treat gravitation as a force added on top of a ready-made spacetime. It does not treat matter as a foreign substance inserted into an otherwise geometric arena. Instead, all three emerge together from the maturation of closure-bearing structure under admissibility. That is a profound shift. In the conventional picture, spacetime is often treated as the basic arena. Matter occupies that arena, and gravity is either a field within it or a curvature of it. However different the formalism, the underlying imagination remains familiar. First, there is a world-shaped stage. Then there is content moving across it. Dark theory reverses the order. First there is recursive differentiation, then stable refinement, then closure, then relation, encoding, and admissibility. Only once these have matured far enough does geometry become possible in the strong sense. Matter and gravitation do not arrive afterwards as independent additions. They arise as structural consequences of how closure distributes itself within the emergent geometric regime. That means geometry is not merely there, it is earned. This point cannot be pressed too strongly because it carries so much of what follows. Geometry in dark theory is not the origin of structure, it is the representation of sufficiently stable structural relation once closure has become mature enough to sustain ordered separation. What earlier sections called encoding now becomes richer, more settled, and more globally supportable. Differences are no longer merely retained locally. They can be organized across a stable relational field. When that happens, extension becomes meaningful, distance becomes meaningful, locality becomes meaningful. A world no longer just has structure, it has shape. But even here, dark theory remains disciplined. Shape is not yet substance, extension is not yet matter, curvature is not yet gravity. Those are further achievements. The key step is this. Once geometry emerges as the representational expression of stable relational closure, the distribution of closure across that geometry cannot remain ontologically irrelevant. Geometry is not a dead container, it is the visible form of structural support. That means variations in support, variations in closure density, and variations in the stability of relational organization must all have geometric consequences. This is where curvature enters naturally. In standard relativity, curvature is treated as the geometric response to energy and momentum. Dark theory does not deny the mature success of that description at the physical level, but it asks a prior question. What is curvature, structurally, before it is written into tensor equations? The answer is that curvature is the geometric signature of non-uniform closure distribution within an admissible relational regime. That is the deeper meaning. If geometry is the representation of stable structural relation, then any variation in the coherence and closure that sustain that relation will appear geometrically as deviation from uniformity. Curvature is not something imposed on structure from outside. It is what geometry looks like when structural support is not evenly distributed. This already begins to change how gravity is understood, because if curvature is downstream of closure distribution, then gravity can no longer be thought of as primitive. It becomes the behavior associated with coherence gradients inside a matured geometric world. A gravitational field is not the first ontological fact. It is the later physical expression of uneven structural support within the closure-bearing regime. This is one of the most elegant moves in the corpus because it means gravity is reinterpreted without being trivialized. Darke theory does not say gravity is an illusion. It does not say curvature is fake. It says that both are real, but not fundamental. They belong to a later stage of reality's ascent. They are what an admissible closure architecture becomes once geometry has emerged strongly enough for variations in structural support to be represented as curvature and experienced as gravitation. This is why the phrase coherence gradient matters so much. A coherence gradient is not merely a metaphor for things being more ordered here than there. It names a structural asymmetry in the ability of different regions of the emergent world to sustain closure. Where closure is deeper, more stable, or more densely organized, the geometry associated with that regime will not be equivalent to a region in which closure is weaker, thinner, or less integratively supported. The world bends according to its own coherence economy. And that brings us to matter. Matter, in Darke theory, is not a primitive ingredient inserted into geometry. It is persistent, closed structure within the geometric regime. This is a very strong claim, but it follows from everything that came before. Once stable closure becomes globally representable through geometry, certain regions of the closure field may not merely contribute to shape in a diffuse way. They may achieve sufficient persistence, internal support, and local structural integrity to stand as enduring concentrations of closed coherence. These are the first true candidates for matter. Matter, then, is not stuff at the deepest level. It is closure that has become persistent enough to maintain itself as a stable geometric inhabitant. It is the local victory of structure over dissolution. It is what the world looks like when closure not only shapes relation but gathers strongly enough to endure as form. This is a more satisfying account than the common habit of simply assuming matter from the outset, because it explains why matter belongs in the same story as geometry and gravity, rather than standing beside them as a separate mystery. Geometry is the representation of matured relational closure. Matter is persistent local closure within that geometry. Gravity is the behavior associated with gradients in closure distribution across that geometry. All three belong to one architecture. That is the real point here. And once seen, it begins to clarify a great deal of the later Darke theory material. Why is gravitation not best thought of as an externally imposed force? Because the world is not an empty arena with force fields written into it. The world is an admissible closure regime whose geometry already reflects its internal support structure. Motion within that world will therefore respond to the geometry shaped by closure gradients. What physics later describes as gravitational attraction is the mature behavioral face of that deeper architecture. Why is matter not ontologically alien to geometry? Because matter is not an imported substance. It is the persistence of closure itself in localized, supportable form. Why is spacetime not primitive? Because the very possibility of a geometric arena depends on the prior ascent through differentiation, recursion, refinement, closure, relation, encoding, and admissibility. So the familiar picture of modern physics is not thrown away but relocated. Relativity becomes a mature descriptive layer, not the ground floor. It captures something true about the behavior of the world, but the reason it works is that the world has already become a closure-bearing geometric regime. The tensor story is not false. It is late. That word, late, matters. Dark theory does not attack established physics by simply denying its successful domains. It says instead, these descriptions become valid only after a deeper architecture has done enough work for them to apply. Geometry is late. Curvature is late. Matter is late. Gravity, in its physical form, is late. They are not wrong. They are downstream. This is also why the corpus treats extreme regimes so carefully. Once matter is understood as persistent, closed structure, and gravity as a coherence gradient, extreme gravitational phenomena stop looking like places where the laws break in some vague, dramatic sense. They become places where closure is being pushed toward its structural limits. Black holes, threshold objects, early compact cosmological anomalies, and similar cases become intelligible as special regimes in which the closure field is no longer behaving like the gentle, near-uniform background assumed by ordinary low-energy physics. That is not yet the whole subject, but the doorway opens here. Because if geometry is closure made visible and matter is closure made persistent, then any sufficiently intense or extreme regime will reveal what happens when closure deepens, compresses, saturates, or approaches terminal limits. The later treatment of black holes, dark matter, LRDs, and cosmic end states all depend on this foundation. There is another layer to this transition as well. Once the world has become geometric, matter-bearing, and gravitating, it also becomes historically thick in a new way. Earlier sections dealt with the emergence of structured persistence in a fairly austere sense. But a geometric and matter-bearing world can now accumulate consequences across scale. It can develop large-scale organization. It can sustain layered histories. It can produce localized concentrations, gradients, threshold crossings, and regions of structural competition. In other words, the universe becomes capable not only of existing, but of evolving. That matters because it ties the physical world back to admissibility. The emergence of matter and gravity does not abolish the economy of support, it intensifies it. Once structure becomes localized and extended, questions of persistence, burden, and threshold become even sharper. Some closure formations will remain stably housed. Others will only persist transiently. Some will generate precursor signatures as they approach inadmissible burdens. Some will reorganize, collapse, or become inaccessible. The physical universe is not a release from structural discipline. It is structural discipline playing out at richer scale. That is why dark theory can move so naturally from foundational ontology into empirical and cosmological claims. The same logic that governed the emergence of stable refinement now governs the fate of matter-bearing regimes. The same admissibility that filtered early structure now filters physical worlds. The same coherence economy that made geometry possible now determines how geometry can bend, gather, and fail. Once this is understood, the next great step becomes available. A world that has become geometric, matter-bearing, and gravitating is no longer merely a structured reality in the abstract. It is a differentiated cosmos. It has local concentrations, large-scale gradients, regions of varying closure density, and the possibility of threshold objects and cosmological anomalies. The next question is no longer how geometry emerges, but how this geometry-bearing universe behaves at scale. This is where cosmology enters dark theory in full seriousness, and once again, the theory refuses the ordinary starting point. Conventional cosmology tends to begin with a universe already framed as spacetime, already governed by a geometric dynamics, already assigned a global expansion history, and then asks how matter, structure, anisotropy, galaxies, and other large-scale features arise within that arena. Dark theory begins earlier. It treats cosmology not as the story of things moving through a ready-made expanding container, but as the history of how closure commits itself to geometry, distributes itself across scale, and produces the structures that a later observer calls the universe. That change is decisive. It means that the early universe is not best understood as a bang in pre-existing space-time. The very phrase already assumes too much. A bang is an event. An event presupposes time. Time presupposes ordered persistence. Ordered persistence presupposes stable structure. Stable structure presupposes closure and admissibility. If the theory has taught us anything so far, it is that one cannot begin by granting all of that and then pretend one has explained origin. Dark theory, therefore, reinterprets the beginning cosmologically as a transition, not a transition from nothing to something in the crude popular sense, and not a transition from one already geometric state to another, but a transition from pre-geometric refinement pressure into committed geometric realization. The beginning on this view is the point at which closure passes from unresolved structural ascent into a regime capable of sustaining geometry strongly enough for a cosmos to appear. That is a very different image from the usual one. The universe does not first exist as a fully meaningful space-time waiting to fill itself with content. It becomes a cosmological world when structural closure deepens to the point that geometry is no longer merely local or fragile, but globally supportable. Cosmology begins where geometry becomes committed enough to bear persistent matter, gravitation, large-scale relation, and durable causal history. This is why the Big Bang, in dark theory, is not treated as an ultimate explanatory primitive. It is, at most, a late descriptive image of a much deeper threshold, the commitment of closure into geometry. The apparent suddenness, heat, density, and dynamical expansion associated with the early universe belong to a phase transition in worldhood, not to the metaphysical origin of being. The real question is not what exploded. It is what kind of structural regime crossed the threshold into geometric commitment strongly enough to produce a universe with history. That shift matters because it also changes how one should think about cosmological development. If the cosmos is the unfolding of a closure-bearing geometry rather than the behavior of matter inside a neutral container, then large-scale structure cannot be interpreted as mere passive content. Galaxies, compact objects, curvature concentrations, voids, clustering behavior, anomalous environments, and early extreme formations all become signatures of how closure distributed itself as the universe became itself. That phrase is worth holding on to. The universe becoming itself. Dark theory does not picture cosmology as the accidental decoration of a pre-given stage. It pictures cosmology as the gradual self-articulation of an admissible closure field into persistent structure across scale. Some regions mature quickly, some slowly. Some commit into deep local closure early. Some remain diffuse. Some accumulate enough structural support to form threshold objects. Others remain only weakly organized. This is what makes the cosmological branch of the theory feel connected to the earlier ontology. The same logic is still operating. The difference is that now it is operating at scale. Once this is seen, the status of threshold objects becomes far more important. A threshold object is not merely an interesting astrophysical phenomenon. It is a regime in which closure has been pushed into unusually deep, unusually compact, unusually informative form. These objects matter because they reveal what the architecture is doing more clearly than gentle background regimes do. They are places where the universe shows its hand. Black holes are the obvious example, but they are not the only one. Any object, class of object, or structural feature that appears unusually early, unusually compact, unusually coherence-dense, or unusually difficult to explain under a smooth gradualist cosmology may be telling us something about how closure commits and concentrates. In dark theory, these are not just anomalies to patch over, they are diagnostics. This is why the theory gives such importance to compact, early structures. If the early universe is a transition into committed geometry rather than a smooth, empty stage gradually populated by matter, then one should expect the possibility of local regions where closure commits more strongly, more rapidly, or more deeply than the surrounding background. Such regions would become natural candidates for early compact systems, early curvature wells, or structurally mature nodes appearing sooner than standard smoothing pictures would predict. This gives a very natural place to the little red dots program. Within a conventional picture, early compact luminous systems with apparent tension against expected formation timescales can seem awkward, premature, or anomalous. Within dark theory, they become much more intelligible. They may represent early closure nodes, local regions in which structural commitment to geometry and persistent concentration occurred sooner and more sharply than the surrounding cosmological field. In that case, their compactness is not accidental, it is diagnostic. It tells us that the universe does not mature uniformly. That is a crucial point. The cosmos, in this framework, is not a perfectly democratic expansion in which all regions participate equally in structural development. It is a burdened and selective field. Some regions carry and commit closure more effectively. Some form deep local basins of persistence, some act as seeds of later organization, some may even reveal the first strong hints of black hole formation, not as exotic foreign disruptions, but as natural consequences of unusually concentrated closure. This also changes how one should interpret clustering and environment. If closure commits unevenly, then the spatial distribution of emergent structures should not be understood merely in terms of matter sprinkling itself across a passive background. One should expect environmental signatures, local enrichments, uneven maturity fields, and clustering patterns that reflect the architecture of structural commitment. Dense nodes may not merely trace later gravitational aggregation. They may encode earlier differences in closure realization. Again, the same logic is at work. The world is selective, not neutral. The emergence of cosmological structure is therefore not just stuff moving around. It is the expression of where and how geometry became capable of housing persistent local closure strongly enough to sustain matter-bearing regimes. Now, we can turn to black holes more directly. In ordinary language, black holes are often treated as almost mythic objects, places where gravity becomes so strong that escape ceases, where space-time curves without mercy, where classical description strains toward singularity. Dark theory treats them more soberly and, in some ways, more deeply. A black hole is not primarily interesting because it is mysterious. It is interesting because it is a threshold object in the strictest sense. It is a region where closure has concentrated to an extreme degree, forcing geometry, persistence, accessibility, and causal structure into a radically asymmetric regime. That changes the emphasis. Instead of beginning with the spectacle of collapse, dark theory begins with the structural question: what happens when local closure deepens to the point that the surrounding geometric regime can no longer treat that region as merely another matter distribution? At that point, one is no longer dealing with ordinary persistence. One is dealing with a closure basin so deep that accessibility itself changes. This is why event horizon language, though useful at the descriptive level, is not the deepest level of explanation here. The deeper fact is that black holes represent closure regimes in which outward accessibility fails before inward persistence does. The object becomes structurally one-sided. Information, transport, and recovery are no longer symmetrically available. The geometry tells the later relativistic story, but the architecture underneath is a story about the asymmetry of accessible closure. This is exactly the kind of regime dark theory should care about, because it connects the ontology of persistence to the later themes of entropy, irreversibility, and terminal burden. A black hole is therefore not just an extreme object inside the universe, it is a lesson about the universe. It shows that persistence can outrun accessibility. It shows that geometry can remain an accurate, mature description while concealing a deeper support asymmetry. It shows that the cosmos contains regions where closure becomes so deep that the normal assumptions of mutual openness and ordinary recoverability no longer hold. And once that is granted, black holes stop being exceptions. They become windows. They show us that the universe is not merely a gentle continuum of similar regimes. It contains thresholds. It contains structural cliffs. It contains regions where the cost of persistence is being paid in a very different currency than it is in ordinary matter-bearing space. That insight also helps with the dark matter question. Dark matter, in dark theory, is not a new invisible particle species added to save a model, nor is it dismissed as a trivial observational error. It is reinterpreted as a consequence of how curvature and closure distribute themselves collectively within large-scale structure. If geometry is the visible representation of structural support, then not all gravitationally relevant curvature need correspond to luminous or baryonic matter in the ordinary way. Some of it may arise from distributed coherence architecture that remains real in its geometric effects, without appearing as conventional matter content. That is why the theory's dark matter move is more radical than a simple alternative fit. It does not merely say there is no dark matter particle, it says the phenomenon points toward a mismatch between how mature cosmology has learned to count matter and how the closure field actually distributes gravitational relevance. In that sense, dark matter effects are not fake. They are the wrong ontology applied to real curvature structure. This is important because it keeps the theory grounded. It does not wave away galactic rotation or lensing anomalies. It says instead that the underlying world may contain collective curvature and closure contributions that are real, measurable, and dynamically consequential without being reducible to an unseen matter bath of the conventional kind. So, at cosmological scale, several things are happening at once. The universe is committing closure unevenly across geometry. Some regions become early compact nodes, some deepen toward threshold objects, such as black holes. Some exhibit collective curvature effects not captured by luminous matter counting. Some remain diffuse, Some organize into clustered environments carrying the memory of earlier commitment differences. That is a much richer cosmological picture than the standard empty stage model allows. And it also tells us why anomalies matter so much in dark theory. Anomalies are not embarrassments to be smoothed away. They are often points where the architecture becomes visible. Whenever the mature descriptive layer begins to strain, the deeper closure logic may be peeking through. Early compact systems, unexpected environmental enrichments, dark matter-like residual curvature, directional effects, anomalous clustering, or strange large-scale structure behavior may all serve as evidence that the cosmos is not simply evolving within a uniform background law, but expressing a selective closure history. This is one of the reasons dark theory is so naturally drawn to cosmological diagnostics. It expects threshold traces. If the universe really emerges through admissible closure and not through brute-furnished geometry, then the large-scale world should still carry scars and signatures of how that commitment happened. Not everything will smooth away. Some structural memory should remain visible in extreme objects. Residual curvature patterns, early compact regimes, and large-scale asymmetries. We are now in a position to say something more exact about cosmology in dark theory. Cosmology is the history of geometric commitment under admissibility. It is the story of how closure became world-bearing at scale, how that commitment distributed itself unevenly, and how the resulting geometry housed persistent matter, threshold objects, collective curvature structures, and evolving large-scale organization. That gives the cosmos a very different emotional and conceptual tone. It is not an explosion fading into emptiness. It is a structural ascent distributing itself through geometry. It is the universe learning how to hold itself. And because it is learning how to hold itself, it also reveals where that holding becomes difficult, asymmetrical, or extreme. Threshold objects are, therefore, not side stories. They are moments of honesty in the cosmological record. They show where the universe departs from gentle approximations and reveals the true burden of persistence. This is why black holes belong in the same line as LRDs, dark matter reinterpretation, and cosmological beginning. They are all facets of one question: how does closure commit across scale? The ordinary physical language changes from case to case, but the underlying question does not. How does structure become durable enough to gather? How does gathering become deep enough to bend? How does bending become strong enough to isolate? How does distributed support become strong enough to mimic unseen mass? How does early commitment outrun gradual expectation? How does a universe pass from unresolved refinement into large-scale organized history? All of those are cosmological questions once the theory is seen properly. There is another reason this part matters. It begins to prepare the road toward entropy and the endgame. Because once the universe is understood as a selective closure field, becoming itself across scale, one can no longer think of cosmic history as an indefinite open canvas. Structural commitment creates possibility, but it also creates burden. Every persistent regime must be maintained. Every concentration, every threshold object, every asymmetry of accessibility, every large-scale organization has a cost. The cosmos is not only becoming more articulated, it is also spending itself in the act of articulation. That means the very success of cosmology contains the seed of its limit. The more the universe commits into durable structure, the more the question of accessibility, recoverability, and support begins to sharpen. Some commitments deepen into isolation, some mature into irreversible asymmetry, some become inaccessible except through residual effects. Some leave behind curvature without luminous content. Some store persistence at the cost of openness. So the cosmological story is not just one of emergence, it is already a story of the future burden of emergence. At this point, entropy enters, but it cannot be understood in the usual shallow way. In standard usage, entropy is often introduced as disorder, or as the counting of microstates, or as a measure of missing information relative to some macro description. These frameworks can be powerful in the domains where they apply, but dark theory asks a more foundational question. What is entropy structurally, in a universe whose whole history is the struggle to achieve, maintain, and distribute closure? The answer is severe and elegant. Entropy is the loss of accessible coherence. That phrase must be understood carefully. Dark theory does not say that entropy is the destruction of all structure. The universe plainly remains structured even in regimes we call entropic. Stars form and die. Black holes persist. Matter distributions remain. Curvature survives. Histories leave traces. If entropy meant simple annihilation of structure, the world would vanish into featureless absence. That is not what we observe, nor is it what the theory predicts. The deeper issue is accessibility. A structure may persist while ceasing to remain recoverably available for further organized use. Coherence may still exist, but no longer in a form that can be reintegrated into future structural work without prohibitive cost. Entropy is therefore not primarily about whether order exists in some abstract, frozen sense. It is about whether the coherence required for generative, recoverable, structurally active organization remains accessible within the admissible economy of the world. That distinction is essential. Because once closure has become matter-bearing, geometric and cosmological, the universe is no longer merely generating structure. It is also locking structure into paths of consequence. Some local achievements remain open and composable. Others deepen into asymmetry. Others become isolated. Others persist only by sacrificing accessibility. Black holes were already an early lesson in this. Persistence can continue where outward recoverability fails. Entropy generalizes that lesson across the whole universe. This is why dark theory's concept of entropy is downstream of closure, not prior to it. You cannot lose accessible coherence unless coherence has first become available in the strong structural sense. Entropy is not primitive. It belongs to a world already rich enough to bear structured persistence, organized transport, recoverable relation, and future directed possibility. Only in such a world does it become meaningful to say that accessible coherence has been reduced, so entropy is not the opposite of structure in some crude sense. It is the reduction of what structure can still do. That is the better statement. A universe may contain enormous amounts of retained form while becoming increasingly poor in accessible future organization. It may remain full of residues, relics, gradients, isolated basins, inert distributions, trapped persistence, and geometrically consequential structures, while still becoming less and less able to support novel, recoverable, generative closure. That is the true burden of entropy. This also gives a new meaning to irreversibility. In ordinary language, irreversibility is often treated as the practical impossibility of going backward, or as statistical improbability relative to microstate counting, or as an emergent feature of coarse-grained thermodynamics. Dark theory again asks the deeper question, why should certain transformations become one way in the structural sense? Because accessible coherence has been spent into forms that can no longer be recovered without exceeding admissible support. That is the core of it. Irreversibility is not magic. It is not a vague universal sadness. It is the fact that some closure-bearing trajectories convert open structural potential into committed outcomes whose coherence, though not necessarily destroyed, is no longer available for reversal as an admissible act. The world can remember what it has done in the form of persistent consequences, yet still be unable to reconstruct the earlier openness from which those consequences arose. That is a powerful thought. It means the arrow of time does not descend on reality from outside. It grows out of the asymmetry between achieved consequence and recoverable possibility. Once a universe has committed coherence into durable outcomes, those outcomes may continue to exist, while the generative openness that preceded them becomes structurally inaccessible. The future remains constrained by the residues of the past, but the past cannot be reopened on demand. This is why dark theory ties time's arrow to structural memory and closure history, rather than to mere clock order. A clock can tick in both directions in an equation. A structure cannot necessarily reopen the coherence it has already committed. That is where temporal asymmetry acquires ontological depth. The universe is not merely ordering moments, it is accumulating consequences, and those consequences alter what remains accessible for further world-making. So the arrow of time is not simply things go from order to disorder. That language is too shallow. The deeper truth is that the universe progressively transforms accessible coherence into committed structure, residual consequences, isolated basins, and inaccessible persistence. It moves from openness to burdened history. This is also why entropy belongs naturally beside cosmology rather than merely inside laboratory thermodynamics. A cosmos built through closure does not merely have local heat processes. Its whole history is a story about the cost of structural commitment. Stars are not just furnaces. They are coherence processing regimes. Galaxies are not just gravitational clusters. They are long-lived closure organizations. Black holes are not just collapsed objects. They are asymmetry machines in which persistence outruns accessibility. Large-scale cosmic development is not merely expansion, it is the spreading and locking in of consequence across scale. Once seen in that light, entropy becomes unavoidable. Every time the universe commits into structure, it gains articulation, but narrows future freedom. Every time local closure deepens, new persistence becomes possible, but certain alternatives vanish. Every time matter organizes, transports, radiates, collapses, or isolates, coherence is being reshaped into forms that may remain real while becoming less available for renewed generative work. This is why entropy, in dark theory, is inseparable from success. The universe does not become entropic because it failed to build structure. It becomes entropic because it succeeded. That line matters enormously. A sterile void with no structure would not be the triumph of low entropy or the catastrophe of high entropy in the sense that concerns us here. The meaningful entropic story begins only once there is enough closure for the universe to spend itself into consequence. Entropy is therefore the shadow cast by successful worldhood. That is one of the most beautiful and brutal claims in the whole framework. The universe becomes rich by committing coherence. It becomes historical by preserving consequences. It becomes irreversible because preserved consequences are not the same thing as recoverable openness. And it becomes entropic because accessible coherence is continually being transformed into less recoverable forms. This also clarifies why dark theory does not collapse entropy into simple randomness. Randomness is not the point. A black hole is not random. A cold, dead remnant is not random. A maximally spread radiation field is not meaningful merely because it is statistically generic. The real issue is whether the coherence relevant to further structured world-making can still be drawn upon without impossible cost. Entropy is therefore fundamentally about accessibility, not appearance. A highly regular but isolated regime may be deeply entropic in the structural sense if its coherence is no longer available for generative use. Conversely, a visibly messy but dynamically open system may still be low entropy in the deeper sense if it retains rich accessible pathways for organized consequence. Dark theory therefore forces a distinction between visible order and accessible coherence. They are not identical. This becomes especially important when one thinks again about black holes. A black hole is not merely a place of destroyed information in some blunt classical sense, nor merely an object whose detailed state is hidden from an outside observer. In dark theory, it is a particularly pure example of coherence remaining real while becoming asymmetrically inaccessible. That is why black holes prefigure the entropic problem so cleanly. They make visible the separation between persistence and accessibility. And that separation turns out to be cosmically general. Across the history of the universe, coherence does not simply vanish. It is redistributed, trapped, diluted, radiated, committed, and rendered inaccessible in different ways. The entropic condition of the cosmos is therefore not a count of how much structure remains in total, but a judgment about how much of the universe's coherence still participates in the open future. That is the heart of the matter. Entropy measures the narrowing of the world's accessible futurehood. Not future in the trivial sense that later times will come, but future as live structural possibility. A low entropic regime is rich in accessible coherence and therefore rich in genuine next moves. A high entropic regime is poor in accessible coherence and therefore poor in admissible next moves, even if many residues of past structure remain scattered through it. This is precisely why entropy belongs next to admissibility in the deep architecture. Admissibility asked, which regimes can the world support? Entropy asks, how much of that support remains accessible for continued structural becoming? One is the filter of existence. The other is the gradual exhaustion of generative openness within what exists. And now, one can see why the endgame is already beginning to cast its shadow. If the universe continually converts accessible coherence into committed consequence, then there is no reason to think the cosmos can remain indefinitely open to fresh structural novelty. It may continue to persist in many forms. It may carry enormous residues. It may remain geometrically real and dynamically describable. But the reservoir of accessible coherence required for new world form cannot remain untouched forever. That is the real meaning of thermodynamic seriousness in dark theory. The universe is not just running down in the vulgar sense. It is becoming progressively less able to reopen itself. That phrase is better than the older clichés. Not the universe gets messier. Not the universe goes to disorder. The universe becomes less able to reopen its own coherence. This makes irreversibility much more than a local physical nuisance. It becomes a cosmological destiny rooted in the very architecture that made the world possible in the first place. Closure gave rise to persistence. Persistence gave rise to consequence. Consequence gave rise to asymmetry. Asymmetry gave rise to irreversible loss of accessible coherence. The same success that built the cosmos now limits its future. That is not a contradiction. It is the deepest continuity in the theory. The world is expensive to build, and expensive worlds cannot remain infinitely open. At this point, the logic is no longer speculative. It has become continuous. Reality does not begin as a finished universe. It begins with primitive differentiation. Through recursion, some differentiation stabilizes. Through stabilization, closure becomes possible. Through closure, relation, encoding, dimension, geometry, and causal order emerge. Through admissibility, the world selects what it can actually support. Through that selection, matter, gravitation, cosmology, and large-scale structure become possible. Through cosmological commitment, the universe becomes itself. And through that becoming, accessible coherence is continually spent into persistence, asymmetry, residue, and irreversible consequence. At that point, the endgame is no longer a dramatic extra, it is the natural, final question. What happens when the universe has committed so much of its accessible coherence that the open future begins to fail? This is where dark theory becomes especially stark. In standard cosmological language, the end of the universe is often described through images such as heat death, proton decay, vacuum decay, big rip scenarios, recollapse, or black hole-dominated late epochs. Each of these pictures attempts to describe some eventual large-scale fate of the cosmos. Dark theory does not deny that some of these may capture parts of the mature physical story under particular assumptions. But it asks the deeper question again. What is the structural meaning of an ending? The answer is not simply that matter spreads out, not simply that temperature gradients vanish, not simply that stars go dark, not simply that black holes dominate and evaporate. Those may all be features of the late description. The deeper issue is this: the universe ends, in the strong structural sense, when it can no longer sustain meaningful, new, futurehood. That phrase needs care. Dark theory does not define the end of the universe as non-existence. The universe need not vanish into nothing for its world-bearing function to be exhausted. A great deal may remain. Curvature may remain. Residual matter or relic fields may remain. Black hole remnants or radiative residues may remain. Geometric structure may remain in some attenuated sense. What fails is something more specific and more fundamental. What fails is the admissible availability of fresh structural becoming. In other words, the endgame is not first about disappearance, it is about exhaustion. This follows directly from everything already established. If entropy is the loss of accessible coherence, then cosmic history is the gradual narrowing of the universe's live structural options. Not every later state is equally rich in future possibility. Early regimes, even when unstable or violent, may be rich in accessible coherence. Middle regimes may support galaxies, stars, life, chemistry, transport, memory, and layered organization. Later regimes may preserve immense residues while becoming increasingly poor in generative openness. Eventually, the cosmos may continue to exist while no longer being able to do very much with what remains. That is the true end. Dark theory therefore treats the universal endgame as terminal closure. Not closure in the early constructive sense where local stability first made worldhood possible. Terminal closure is something darker. It is the condition in which structural commitment has advanced so far and accessible coherence has thinned so much that the universe becomes effectively closed against new, large-scale novelty. The world still bears the consequences of everything it has become, but no longer retains the openness required to become meaningfully otherwise. This gives the endgame a very distinctive character. It is not simply thermal equilibrium in the old textbook sense, though some aspects of thermal flattening may belong to it. It is not merely maximum disorder, because disorder is too crude a word. It is not merely emptiness, because residues may still persist. It is not merely silence, because processes may still occur in attenuated, trivial, or local ways. The endgame is the exhaustion of structurally available nextness. That is the more exact phrase. A universe can continue after its future has already failed in the strong sense. It can retain persistence without retaining possibility. It can carry history without remaining open to meaningful new world formation. It can survive as consequence while no longer surviving as becoming. This is one of the most important distinctions in the whole framework. Dark theory is not primarily concerned with whether something still exists at the end. It is concerned with whether existence still carries open generative depth. The cosmos becomes terminal when persistence remains, but futurehood no longer has real structural room to operate. This is why the endgame belongs directly downstream of admissibility and entropy. Admissibility asked which regimes can be supported. Entropy tracked the loss of accessible coherence within those regimes. The endgame is what happens when that loss becomes global enough that new admissible organization at meaningful scale is no longer available. At that point, the universe has not merely aged, it has spent itself. That phrase matters. The universe spends itself by becoming. Every star, every galaxy, every black hole, every concentration of matter, every coherence gradient, every local victory of structure over dissolution is part of that expenditure. The cosmos does not move toward its end because it failed to organize. It moves toward its end because organization has consequences. Every commitment narrows future freedom. Every achieved persistence leaves behind burden, asymmetry, and locked consequence. The world is richest when accessible coherence is abundant, but abundance does not survive untouched by use. So the endgame is not a punishment, it is the price of reality having succeeded at all. This is also why dark theory's end-state picture is more unified than many standard cosmological endings. In standard discourse, one often gets multiple unrelated fates of the universe, as though the cosmos were waiting to choose among several cinematic possibilities. Dark theory instead asks what all such late-state descriptions have in common at the structural level, whether the mature physical details include decayed matter, diluted radiation, isolated remnants, evaporated black holes, or asymptotic flattening. The deeper question is always the same. How much accessible coherence remains for continued world-making? If the answer trends to effectively none, then the endgame has arrived, whatever the surface phenomenology. That makes terminal closure a higher-order unifier. It does not replace physical modeling of late-time cosmology. It tells us what those models mean if the world is fundamentally built through closure, burden, and admissibility. The universe ends when the support conditions for genuine new structure have been exhausted. All late physical scenarios are secondary to that deeper criterion. This also casts black holes in a new light again. Earlier, black holes appeared as threshold objects, showing that persistence can outrun accessibility. In the endgame, that lesson becomes cosmological. The whole universe begins to behave, in a diffuse and global sense, more like a field of inaccessible residues, not because everything becomes a black hole, but because the logic black holes expose becomes widespread. Coherence persists, but no longer in forms that can be readily reopened for future structural use. The endgame is therefore a generalization of that asymmetry. The universe does not lose all trace of what it has been. It loses the ability to turn what remains into further rich becoming. This is why the phrase exhaustion of futurehood is better than the older cliches. Heat death suggests mere thermal flattening. Cosmic death suggests disappearance. Maximum entropy suggests a purely formal or statistical endpoint. But exhaustion of futurehood says exactly what matters in Darke Theory. The world has run out of admissible open depth. It may continue as residue. It may continue as geometry. It may continue as attenuated persistence, but it no longer continues as a generative universe in the full sense. That is the end. There is another profound consequence here. If the beginning of the universe is not an event inside time, but the transition from under closure into committed worldhood, then the end of the universe is not simply the last event in time either. It is the opposite threshold. The beginning is the emergence of enough closure for geometry, persistence, and futurehood to become possible. The end is the saturation of closure to the point that futurehood can no longer remain open. This gives the entire cosmos a deep symmetry. The beginning is not absolute nothing. It is under closure with high generative freedom. The end is not absolute nothing either. It is over closure with vanishing generative freedom. That symmetry is one of the most beautiful parts of the theory. The universe opens when structure first becomes supportable. The universe closes when supportable novelty is exhausted. So the whole cosmological arc can be written as a passage between two limits, from unresolved generative potential to terminally committed residue. That is not merely poetic, it is a direct consequence of the architecture. This also clarifies why Darke Theory refuses to treat time as fundamental. Time, in the mature physical sense, belongs to the middle. It belongs to the regime in which futurehood is live, consequences accumulate, and structural openness is still sufficiently available for meaningful becoming. The beginning stands before that middle in a pre-geometric ascent. The end stands beyond it as a regime in which persistence remains, but future-directed generativity has thinned toward exhaustion. So time, as we experience and model it, is bracketed by two thresholds, the opening of futurehood and its terminal depletion. That is a much deeper account of cosmic history than the usual one. It is not time starts, things happen. Time continues forever, or stops. It is this. Futurehood becomes possible, matures, spends itself, and eventually fails. That makes the universe feel less like a machine and more like a structural life cycle. Not biological life, of course, but world life, a finite arc of becoming made possible by closure and limited by the consequences of closure. This is why the endgame in Darke Theory is not a gloomy add-on. It is the completion of the logic. If the cosmos is built through admissible structural success, then the exhaustion of admissible futurehood is the only truly coherent ending. Any late-state picture that leaves infinite open novelty untouched would sit uneasily with the burden logic that governs the rest of the theory. The universe cannot spend accessible coherence indefinitely and still remain infinitely generative. That would break the very architecture by which it became possible. So terminal closure is not one option among many. It is the deepest expectation of the framework. And now, with all of that visible, the full arc can finally be seen at once. What began as a question about foundations has become a complete cosmological line, not a loose collection of themes, not a set of disconnected reinterpretations, but one continuous sequence running from the earliest admissible structural beginning to the exhaustion of cosmic futurehood. That is the real achievement of dark theory. Because the theory is not trying to offer a local patch to physics, it is not merely proposing a new account of gravity, or a new gloss on entropy, or an alternative reading of black holes, or a different story about dark matter. It is doing something much harder. It is trying to identify the structural order in which the world itself becomes possible, and to show that once that order is respected, many of the deepest puzzles of modern science stop looking unrelated. They begin to look like different stages of one unfolding. We begin properly, not with matter, not with stars, not with space, not with time, not with a singularity, not with a law already written into a ready-made universe. We begin with the least that can be admitted without cheating, differentiation. Reality does not begin as a furnished arena, containing entities that are already distinct. Distinction itself must come first. Before any object can exist, before any geometry can separate one region from another, before any duration can order one state after another, there must be the primitive possibility that one determination is not identical to another. That is the first cut. But difference alone is not enough. Bare differentiation does not yet give us a world. A fleeting distinction with no capacity for retention cannot support persistence, relation, or consequence. So the earliest structural domain must be subjected to recursion. Differentiation must act back upon differentiation. What appears must be revisited. What is formed must bear return. This is where the universe first becomes selective. Once recursion enters, not every structural pathway survives. Some differentiations collapse under re-entry, some dissolve, some fail to maintain enough consistency to remain available. Others begin to hold. They retain themselves through repeated refinement strongly enough to become recognizable as stable structural achievements. That is the birth of stable refinement. And with stable refinement, identity appears for the first time in a serious ontological sense. Not identity as eternal essence, but identity as retained structural survivability. A pattern becomes itself because it can endure recursive return without being erased by it. Stability is not granted, it is earned. From there, structure ascends toward closure. A refinement that remains only weakly stable is not yet enough to build a world. To support further organization, it must become internally supportable. It must cease leaking its structural character under the very operations that formed it. This is what closure means in dark theory. Closure is not decorative completion. It is the achievement of a regime in which structure can hold itself strongly enough to remain available for deeper integration. And once closure appears, the world changes, because closure makes relation possible. A stable but isolated refinement is still only a local triumph. A world requires more than local survival. It requires that retained structures can enter into meaningful relation without ceasing to be themselves. Closure opens that possibility. Once structures can participate in one another's continued form without collapsing, integration begins. And with integration, relation ceases to be accidental. It becomes architectural. That allows encoding. Differences can now be preserved as part of a larger order. Distinctions are no longer just local survivals. They can be carried, registered, and composed across a structured field. This is where dimension first becomes thinkable, not as an already given container, but as a stable basis of organized distinction within a closure-bearing relational regime. That is the first outline of shape. From encoding and stable basis, geometry emerges, not primitive geometry, not an eternal space-time stage. Geometry is a later representation of sufficiently matured relation. Space becomes meaningful only once structural separations are stable enough to be born across an organized field of closure. Extension, locality, and distance are not prior to structure. They are what structure becomes when closure has succeeded deeply enough. The same is true of causality. Causality is not a primitive law imposed on a featureless domain. It arises only once stable relation, persistence, and ordered transformation have become possible. Before closure, one may have variation, tension, and recursive activity, but not yet causal order in the strong sense used by physics. Cause and effect belong to a world already rich enough to retain its own transformations. At this point, the first shape of a universe exists, but a shaped world is still not the same as a supportable world. Once relation, geometry, and persistence have appeared, a harder question comes into view. Which regimes can actually endure within such a world? This is where admissibility enters. Admissibility is one of the great hinge concepts of the entire framework. It is the principle that says formal describability is not enough. A regime may be mathematically articulate and still fail to be structurally supportable. Existence has a cost. Coherence must be housed. Persistence must be paid for. Integration must be maintained. If a regime demands more support than the architecture can provide, then it may remain writable, but not realizable. Reality is not the set of everything that can be described. It is the residue of what can survive the burden of its own existence. Some regimes are fully admissible and can persist durably. Some are only transiently admissible, appearing as threshold states, precursors, or local tensions. Some are inadmissible in the strong sense, because the world cannot carry them at the width, duration, or coherence they require. This gives the whole theory its teeth. The world is not a warehouse of abstract possibilities. It is a coherence economy. And once admissibility is established, the mature physical universe can finally emerge on proper terms. Geometry now deepens into curvature, because geometry is not a dead container but the visible expression of structural support. Variations in closure distribution must have geometric consequences. Where closure is uneven, geometry cannot remain flat. Curvature is therefore not an alien feature pasted onto spacetime from outside. It is what geometry looks like when structural support is distributed non-uniformly. That is the deeper meaning of curvature. And from there, gravity follows naturally. Gravity is not primitive in dark theory. It is the mature physical behavior associated with coherence gradients inside a closure-bearing geometric world. What relativity later describes as gravitational response is real but not foundational. It belongs to a later stage of the architecture when geometry has emerged strongly enough for variations in closure density to appear as curvature, and to govern motion accordingly. Matter appears within the same story. Matter is not ontologically foreign to geometry, it is persistent local closure within the geometric regime. It is what the world looks like when closure gathers strongly enough, stably enough, and durably enough to stand as a concentrated inhabitant of geometry. Matter is not stuff injected into a stage. It is closure made persistent. Geometry is matured relational closure made visible. Matter is local persistent closure within geometry. Gravity is the behavioral expression of gradients in that closure across geometry. These are not three separate metaphysical primitives. They are three aspects of one structural achievement, and once they exist, cosmology begins, but not in the conventional way. Cosmology in Darke Theory is not the story of content moving through a pre-given expanding container. It is the history of how closure commits itself to geometry at scale. The early universe is not best understood as a bang inside meaningful spacetime. It is the transition from pre-geometric refinement pressure into committed geometric worldhood. The origin is not a first event in time, but the threshold at which closure deepens enough for geometry, persistence, and history to become globally supportable. That is the true beginning of the cosmos. The universe then becomes itself unevenly. Closure does not commit at identical rates everywhere. Some regions deepen early, some remain diffuse, some gather into compact nodes of persistence, some generate strong local curvature wells, some reveal environmental enrichments and clustering behaviors that standard gradualist pictures struggle to accommodate. In Darke Theory, these are not embarrassments. They are diagnostics. Threshold objects matter because they reveal where the architecture is most honest. Early compact systems, including the little red dots, are not merely curious early galaxies that formed too soon. They may represent early closure nodes, local regions where structural commitment to persistent geometry occurred more sharply, more deeply, or more rapidly than in the surrounding field. Their compactness is therefore not incidental. It is evidence that the universe does not mature uniformly. The same logic reframes black holes. A black hole is not simply a place where gravity is extreme. It is a threshold object in which closure has concentrated to such depth that accessibility fails before persistence does. That is the key structural asymmetry. The regime continues to exist. It persists intensely. But the openness of relation to the surrounding world is radically altered. Outward accessibility collapses while inward persistence remains. That makes black holes lessons about the universe, not mere exceptions within it. They show that coherence can remain real while becoming inaccessible. They show that persistence can outrun recoverability. They show that the cosmos contains regions where ordinary mutual openness fails under the burden of deep structural commitment. And that same insight reframes dark matter. Dark matter effects are not dismissed in Darke Theory. They are taken seriously but interpreted differently. If geometry is the visible form of closure distribution, then not all gravitationally relevant curvature need correspond to luminous baryonic matter in the ordinary counting scheme. Collective curvature and distributed closure architecture may remain dynamically real without showing up as conventional matter content. In that sense, dark matter is not nothing. It is a mismatch between the ontology of curvature and the ontology by which standard cosmology counts matter. So the universe by this stage is fully itself, matter-bearing, gravitating, geometrically committed, cosmologically uneven, rich in threshold objects, and full of structural consequence. And then entropy begins to matter, but not as mere disorder. Dark theory treats entropy as the loss of accessible coherence. Structure does not simply vanish as the universe becomes entropic. Much remains. Matter remains. Curvature remains. Black holes remain. Residues remain. What changes is accessibility. Coherence may still exist, but no longer in a form recoverably available for further generative structural work. That is the true cost. Entropy is not primarily about ugliness, randomness, or mess. It is about the reduction of what the universe can still do with the coherence it contains. Accessible future organization narrows, recoverable openness thins. The world becomes progressively less able to reopen itself, and from that, irreversibility follows. Irreversibility is the fact that structural commitment leaves consequences that persist while the openness that produced them becomes inaccessible. The universe remembers what it has done in the form of retained residues, stable asymmetries, and locked outcomes, but cannot simply reconstruct the live field of possibilities from which those outcomes emerged. The arrow of time is not imposed from outside. It grows out of the asymmetry between achieved consequence and recoverable possibility. That is why time is late and finite in spirit. Time belongs to the middle of the story, the regime in which futurehood is genuinely live. It opens only once closure and persistence have matured sufficiently, and it becomes exhausted once accessible coherence has been spent too deeply into irreversible history. Time, as the cosmos meaningfully experiences it, is bracketed by two thresholds: the opening of futurehood and its eventual depletion. This leads directly into the universal endgame. The end of the universe is not simply non-existence. It is not merely darkness, thermal sameness, or the absence of stars. The universe ends in the strong structural sense when it can no longer sustain meaningful new futurehood. Persistence may remain, residues may remain, geometry may remain in attenuated form, but the open depth required for further rich structural becoming has been exhausted. That is terminal closure, and it completes the cosmic symmetry. The beginning of the universe is under closure, with high generative freedom. The end of the universe is over closure with vanishing generative freedom. The beginning is not absolute nothing. The end is not absolute nothing either. The cosmos opens when structure first becomes supportable enough to generate worldhood. It closes when supportable novelty has been spent so far into consequence that new world-making is no longer admissibly available. The whole universal arc is therefore the passage from unresolved generative possibility to terminally committed residue. That is the full line, and that line is strong because each stage inherits from the previous one. Nothing is simply asserted, nothing is imported freely. Every layer must earn the next. The theory is not trying to add one more model to an overcrowded shelf. It is trying to reorder the shelf itself. The deepest sentence one can say about the cosmos in this framework is not that it began with an explosion and ends in silence. It is this: the universe began when difference first learned how to hold itself, and it ends when what it has become can no longer reopen into anything new.